Hi, hello everyone. Good morning. I'm Dr. Abdul Pasha, Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad, working in Department of Electrical and Electronics Engineering. So here it is continuation about the course Power System Operation and Control. So in this case, we are discussing here some types of the fax controllers introduced. Earlier we discussed some concepts regarding fax controllers. So in this case we will discuss what are the various kinds of fax controllers introduced into the power system network. So generally fax controllers are introduced to compensate for something in the lag of the power system network case. So they can be supposed to be classified into 4 categories. One is about series controllers. Second one is about shunt controllers. Third one is about combined series controllers. Fourth one is combined series shunt controllers. Means when you are using these 4 cases as one of the major classification in fax controllers, so based on the transmission network parameters and their design considerations, we are going to insert these controllers, as they may be connected in cascaded or in a parallel manner. So in some cases we may treat the combination of this series aided and series shunt aided controllers. So these are ready to occupy the line compensations and which gives the performance of the transmission lines, and because of that these controllers are ready to work smoothly. So principle of series controller here is to inject the voltage in series with the line. Here the main purpose is served by the series controller is to compensate for the voltages. So even variable impedance is supposed to be treated as one of the multiplication coefficient by the current flow through it, but it will represent an injected series voltage into the line case. So long as the voltage is in phase with the quadrature with the line current, then series controller is ready to supply or consumes the variable reactive power. So if any other phase relation is supposed to be involved into the system, then it will ready to handles for the real power case also. So here in the event of the variable impedance means that should be treated as one of the multiplication coefficient for the current flow case, as when it is supposed to be injected by some voltage into the series line, so that voltage is in phase with the given current. So series controller is ready to give the consumable to the reactive power case. As we discussed the reactive power compensations, that also to be one of the important key feature in line parameters. If any one of the phase relation is existing, means it will treat for a real power coefficient P. This is called real power coefficient. Real power coefficient. So as series controller, shunt controllers also to be variable impedance, variable source, or we may treat it as the combination of all the cases. So principle of shunt controller here is introduced to inject the current into the system at the point of connection. That means even variable shunt impedance may be connected to the line voltage. This may causes variable current flow, and hence it will represent the injection of the current into the line. So as long as the injected current is in phase with the quadrature, that should be treated with the line voltage. So that means as series controller cases are supposed to be having the variable impedances case, means that combination is cumulatively treated for all the controllers. That means whatever the parallel combination that we treated at the point of connection, that parallel impedance connected to the line will causes the variable current to flow. So this will represent the injecting of the current into the line case. This injected current is supposed to be treated in phase with the line. So shunt controllers are ready to supply our consumers variable reactive. That means in any other phase relationships, if it is existing, then it will be treated to handle real power cases. So combination of two separate series controllers which are supposed to be controlled in a coordinated manner, and in a multi-line transmission system these are most important. Otherwise it could be unified controller in nature. So our series controllers are ready to provide the independent series reactive compensation. That means it should be treated for each line and also ready to transfer the real power among the lines through the unified series controller case. So this should be referred to as interline power flow controller. That means IPFC is going to be treated. Just like UPQC, IPFC also makes possible to balance both the real and reactive power flow constants. That should be connected to the entire line, and thereby it should be maximizing the utilization of the transmission system. So here we should remind that unified means DC terminals of all the controllers converters, they are connected together to form the real power transfer. So here the principle of that combined shunt series controller is it injects the current into the system with the shunt part of the controller and voltage through the series part case. So however, when the shunt and series combinations are unified in nature, there should be a real power exchange in between the series and shunt controllers through the power link case. So what are the benefits derived from the FACT controllers? As we introduced one of the FACT controller as a series compensation and shunt combination, and also to be the combinational aspects of series and shunt. So control of power flow is in order that to meet the utilities and own needs that will ensure optimum power flow, and it should raid through the emergency conditions, or it may be treated as combination of all the cases. So that increasing the loading capability of the lines to their thermal capabilities. That may include short-term and seasonal effects. So this can be done by overcoming the other limitations and sharing the power among the lines. That should be done according to their capability of the system. So here some more other benefits derived from the FACT controllers are that will increases the system security through raising the transient stability limit. As we treat one of the transient stability limit means these are implied with the one of the suitable conditions as limiting short circuit currents and overloads, managing the cascading blackouts that may treat the damping electromechanical oscillations. That should be converged for all the power system networks and the machines cases. So this should be ready to provide secure tie line connections. This should be done to neighboring utilities and regions. So thereby it will decreasing overall generation of the reserve requirements of both the sides. So as providing greater flexibility in settling the new generation, which will be provided with upgrade of the lines. So here some more benefits over this considering FACT devices is to reduce the reactive power flow, and by that it will be ready to allowing the lines to carry more active power. As more active power is carrying into the line means it will ready to reduce the loop flows. So one of the loop flows are considered as more major number of the loop flows are going to be treated. So all these are the loop flows. This is loop 1, loop 2, loop 3, loop 4, loop 5, 6, 7, 8, 9, 10, 11. Like that we can consider number of loop flows. N is the number of loop flows. Then for that whole number of loop flows, that will increases the utilization of the lowest cost generation. So here what happens means as the number of loop flows are more, then this will make sure about reducing all the contents of the loop flows. and also it will ready to increase the utilization of the lowest cost generation. So as voltage source converters are treated here, then operation of single phase bridge inverter is considered. A single phase bridge inverter is containing 4 valves, that is valve from 1 to 1 dash, next valve from 2 to 2 dash, all these are the valve cases, 2 to 2 dash, 3 to 3 dash valve, 4 to 4 dash. So these are the valve cases, 1 to 1 dash, 2 to 2 dash, 4 to 4 dash. All these are the valve cases. So here is a capacitor. This is ready to provide a stiff DC value. What is this stiff DC value means? As constant voltage is going to be operated. Constant voltage is going to be considered. So because of this insertion of C into the line, what happens means as voltage stability will be increased. Voltage stability is going to be enhanced because of as it should be providing with the stiff consideration of the DC value into the capacitor network. So as voltage and two AC connection points of A to B or A and B treated, then designated value numbers will ready to represent their sequence of turn on and turn off operation. As voltage and two AC connection points of the A and B considerations, then designated value numbers means it will represent the order of the turn on and turn off of the operation. So this will make sure about the line to make along the length of the line as it goes on increasing. So this is the diagram will better explains about single phase full wave bridge converters we are using into the line. So it contains suitable supply voltage as VD and capacitor C across the terminals of the elements which are connected from 1, 1, 2, 1, 3, 1, 4, 1 cases. So as it should be connected in parallel with the capacitor into the line means, so this combination will be treated to the supply terminals of the transformer. As the real and reactive power coefficients are treated much more, the second end will be treated with the AC system case. So this AC system will ready to generate the power onto the secondary end to make sure about the line as along the single phase full wave bridge converters. So it contains two set of elements. So each set contains two elements that may be treated with 1, 2, 3, 4 lines. So this combination may be treated as one of the set to work as full wave bridge converters case. So here DC voltage is first converted to AC with appropriate valve turn off sequence. So as it is discussed earlier means as it will be treated on state condition and off state condition. So as in the first wave, when devices are 1 and 2, they will be turned on the voltage. Then VAB becomes plus VD, that means positive DC voltage for one half cycle. And when devices are 3 and 4 turned off, then VAB becomes minus VB for the other half cycle. So suppose the current flow is existing in AC waveform which is a sinusoidal wave, that will use the IAB which an angle theta leads to the respect of the square wave voltage wave. That should be forming T1. The operation is supposed to be executed under these conditions with the DC voltage as VD and one of the voltage VAB, and according to the number of cycles, this sequence will follow the main line coefficients. So this is the output wave representation for considering to the main circuit, as this circuit is considered here. Then the representation of the output when the devices will turn on sequence aspects, and it is treated for 1 and 2 on. 1 and 2 is on, 1 and 2 elements are on. Then peak of the wave is considered in the positive case, and when it is under 3, 4, then the wave will follows for a negative peak, and when it is following 1 and 2 on, then it should be following another sequence. Like that, 3 and 4, 1 and 2 will be treated under 1 and 2 and 1 and 2 on. That sequence only follows in the positive half cycle. The remaining 3 and 4 will follows in the negative half cycle. As it is following the device sequence, then the combination may exist 1 to 1 dash and 2 dash combination. And the upper combination with 3 4 and a 3 dash 4 dash combination, and 1 2 sequence will automatically follow. So all these sets of combinations, they are supposed to be triggered at the aspect of T1, T2, T3, T4, T5, T6. For that respective time periods, the current combinations will be follows. According to that sequence, the output sequence will be followed. For 1 2 combination, it becomes 1 dash 2 dash. And 3 4 combination, the combination becomes 3 dash 4 dash. Again the sequence same will be repeated, 1 2, again 1 dash 2 dash, for 3 4, 3 dash 4 dash. Like that the sequence is going to be continuously following. With respect to that, we can generate the output voltage as it is pulsating in nature. Which is pulsating in nature, they differed by the angle theta. This is called output waveform representation. So from the instance of T1 to T2, what happens means when the devices are 1 and 2, they are supposed to be turned on, and 3 and 4 they are supposed to be turned off. Then VAB is positive and current becomes negative at the point of IAB. That is, so VAB is treated positive and IAB is treated as negative. This is to be happens from instant T1 to T2. So 1 2 becomes on, 3 4 off. Like that sequence of the parameters will follow. So current flows through the device 1 into AC phase, and A and then output of AC phase, then B through the device 2 with power flow from DC to AC. So as a DC to AC conversion is existing means, that is to be called as inverter operation. Inverter operation exists with the conversion of DC to AC. So from the instant of T2 to T3, so current becomes reverses and it becomes positive, and it will ready to flows through the diode combinations as 1 dash and 2 dash. So this is to be done with respect to the power flow from AC to DC case. As we know that should be treated as one of the rectification operation. So rectifier is ready to convert AC power into DC power. So that should be done in this case. So from the instant of third and fourth combination of the device at T3 and T4, so 1 and 2 elements are going to be turned off and 3 and 4 are going to be on. Then your VAB becomes a negative and IAB is still positive, as the current flow through the device is 3 and 4 with respect to the power flow from DC to AC is going to be existing. So this is to be known as inverter action. This is called as inverter action. So from the instant of T4 and T5, as the devices existing 3 and 4, still they are in on state condition, and 1 and 2 becomes off, then VAB becomes negative. So current IAB going to be reverses and should be flowing through the diode combination as 3 dash and 4 dash. So with these cases, 4 operating modes is one cycle existing for the single phase converter. That should be represented here with a simple tabular representation that we will see now here. So this is the operational mode of the given single phase full wave bridge converter. The first case is order follows as 1 2 3 4 order of the sequence case. As the devices are existing in on state and off state condition, then VAB IAB is going to be treated. As first and second devices are going to be turned on, and similarly third and fourth devices are going to be turned off, then your VAB becomes negative here, positive here, and this becomes negative here. So what are the conducting modes of the devices means 1 and 2 only conducts, that will be turned on, and 3 and 4 will comes to the off state condition, as this conversion existing as inverter mode of operation. And the order follows for when 1 and 2 is existing and 3 and 4 is turned off. Then VAB becomes positive and IAB also be positive. Both are positive in nature. Then the conducting devices are to be 1 dash and 2 dash. They may resultant as rectifier cases. Similarly, for the third order of sequence, 1 and 2 is going to be turned off. Then your third and fourth device is going to be non-state condition. So because of this, VAB becomes a negative, IAB becomes positive in case. So conducting devices are here 3 and 4 existing in nature. So because of that conduction of 3 and 4, 1 and 2 becomes off state. So this mode of element is under inverter operation. Similarly, for the fourth order, 1 and 2 will be treated as off and 3 and 4 will be on state condition. So this becomes VAB is under positive combination and this will be negative combination, means the third and fourth, 3 dash and fourth devices will come into the conducting mode of operation. So this should be treated as one of the rectifier operation. So as rectifier operation existing with conversion from AC to DC case. So finally, as the conversion is made, then we will see 2 of inverter operation and 2 of rectifier operation. So inverter and rectifier operations will be existing for this system. So this is about a 3-phase full wave bridge converter as it is existing from P to VD under the neutral point, and the system is existing with 1 dash and here 2 dash is existing. This is about 3 dash and this is about 4 dash. This is 5 dash and 6 dash. So as the delta to star conversion is existing for the light, so the flow of the current that should be taken from the clockwise direction as it is existing in this manner. So when it is existing in such a manner, it will consume the power. As 2 capacitors are connected in cascaded manner, that whole combination is connected as in parallel with the sets of the devices. So because of this conduction, 3-phase wave converter with 6 valves that are existing from 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, 4 to 4 dash, 5 to 5 dash, 6 to 6 dash. Like 6 combinations will exist. 6 combinations will exist. So 1 to 6 represents the sequence of the valve operation in on time. That means it contains 3 legs. They will differ by 120 degrees phase shift. So that 3-leg combination will operate in a square wave mode. So this will be treating under square wave mode. This is the mode of operation when it is conducted. So each valve is alternatively closes for 180 degrees phase shift as it is existing in the waveform. So these 3 square wave waveforms are going to be the voltage of AC buses with A, B and C, that is done with respect to the A case. So DC capacitor is at the midpoint with N with the peak voltages of plus Vd by 2 and minus Vd by 2. So these 3 phase legs, they have been defined with the phase angle about 120 degrees phase shift. This is to be done with respect to the 6-phase converter operation with the phase leg combination from 3 to 6 is existing as the switches are 120 degrees apart from the phase leg, as 1 to 4 combination is considered and the phase leg 5 to 2 is switches about 120 degrees phase shift with 3 to 6, thus it will completing the cycle as shown by the valve that will close to open the sequence. So to make the turn on and turn off operations of the devices, it will be ready to establish the waveforms. That means this is existing with the AC bus voltages in relation to the DC voltage case. That means current is ready to flows itself. So as because of that, the result of the interaction of the AC system may follows. That means voltage with the DC system is going to be treated. So each converter with a phase lag can handle the resultant current flows in either of the directions. So because of that, so the total AC current IA in phase with the A with the positive current representing the current from AC to DC side, for simplicity it is going to be considered. So the current is assumed to have fundamental frequency only here. So because of that, it should be existing from the point of 1 to point of 2. This is called as fundamental frequency operation. Fundamental frequency operation. This is usually existing from 1 to 2 point. So as it is existing from the point of 1 to 2 means here the coefficients must be positive in nature, as the current flows from the phase IA with respect to the positive current. When the voltage is DC in nature, then each converter with the phase lag can only handle to resultant current flows in both the directions. So current can handle in both directions, I positive here also. So current will existing in both the directions because of the turn on and turn off of the devices. They will establish the waveform as AC bus voltage into the DC voltage. So current flow must be existing. That means it will be the result of the one of the interaction of the AC. So as the AC to DC conversion as rectifier is existing, that means current is assumed to have only fundamental frequency. So because of this nature of the system, they may undergo the inverter and rectifier operation for the 4 cases of the network as it is given in the operational modes of full wave bridge converter case. So when one set of the devices are in on state and remaining set will be acting in off state position. So likewise it will be operating for inverter mode, rectifier mode of operation, inverter mode and rectifier mode of operation. So these are the various modes of operations with the system it can execute for the whole network. So these are the some of the references whichever I have taken, and this presentation will elaborate the operations of the rectifiers, inverters. Some more from the courses we can introduce, and this may give the better view of the lecture contents and PDF analysis from the content which will be inserted into the system. That gives the suitable results. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.